Jen Greenwood's here to talk about their projects. And I would just, the PEO LCS program is currently building in production on the LCS systems, but they're also starting a development program for the, I guess they're calling it the Fast Frigate.
Fast Frigate.
And so I think you're going to be seeing more LCS efforts going along as their R&D gets pumped into their programs to make the next generation available to the rate.
Okay.
Okay.
Good morning. My name is Jen Greenwood. I am the SBIR coordinator for PEO LCS. I'm going to warn you, I don't have an engineering background at all. My background is Air Force targeting, so bear with me on some of the more high-tech topics, and I'll point you in the right direction. LCS is a bit of a different platform for the Navy because we have two different hull types. We have the monohull, which is the Freedom class, and we also have the trimaran hull, which is the Independence class. And some of our SBIRs are written specifically for one of those hulls, so you kind of want to make sure that when you're reading the topics, you're looking at what hull it's specifically addressing, so you can tailor it towards that specific hull type. Another thing that's kind of different about LCS is we have interchangeable mission packages, which allows the ship to dynamically shift its mission that it's working on by pulling into port, and it'll swap out crew and equipment and take on a new mission package. So some of our SBIRs are related to different mission packages, and it'll go on different ships, or it may be a hull specific topic. So you want to kind of look at those. We have an anti-submarine mission package, a surface warfare mission package, and a mine warfare mission package. So all three of those are something that's interchangeable. LCS also has a very low margin for weight control. So almost all of our SBIRs are very specific as far as weight goes. We're looking for something that's going to reduce the weight of the platform. And one thing it drives a lot of our SBIR topics. So a lot of our topics are specifically addressing weight control issues. So when you write your proposals or respond to the RFPs, you want to make sure that you're addressing those weight concerns and that your technologies are going to stay within the weight specs, because that's one thing that will take you out of consideration completely, is if you can't address the weight issue if it specifically outlines that. And that also goes for, we do a lot of different unmanned systems. So we work with the Fire Scout UAV. We have an unmanned underwater vehicle as well as an unmanned surface vehicle that we're working on. So those also, if they ride on the LCS, they have a weight consideration as well. So our first topic is one that specifically addresses weight control on the Freedom class. And this is for high temperature superconductors. That's one of our weight control measures, is that we've gone from conventional cabling to high temperature superconductors, and it really drops the weight considerably. The high temperature superconductors normally require liquid nitrogen for cooling. However, the liquid nitrogen is not very useful in the Navy, onboard Navy ships, because it doesn't, it has a safety and a logistical issue that we can't put it on board ships. So we're currently using cryo-cooled helium to help keep the cooling down on the high temperature superconductors. So we also use a vacuum to do this, because the vacuum reduces heat transfer to the cryogenic spaces. So the vacuum tends to break down over time. So we're looking for a ruggedized condition-based vacuum that is basically going to be an autonomously maintained system, so it'll be more durable and it'll reduce maintenance. And that's kind of what this topic is specifically addressing. The topic author is Jacob Kephart, Dr. Kephart. His phone number is 215-897-8474, and Stephen Kreider, 215-897-1928. And the technology manager for the SBIR program in LCS is Patrick Carver. I also know several of the people who work these issues specifically, so if you have questions and you can't contact those gentlemen, please reach out to me directly and I can put you in touch with someone who can clarify your issues. So actually one of our S&T team members is a patent holder on the high temperature superconducting system, so he may be able to, or I can get you the answers that you need to address those. Our next topic is shallow water communications for mine warfare. And one of the things that we're very kind of adamant on our mine warfare mission package is getting the man out of the minefield. So a lot of our topics address those abilities, is to make our mine warfare situations a little bit more efficient and a little less human-centric. So what we're trying to do here is develop a wireless secure network, a comms capability, to basically turn off, turn on, and reprogram mine targeting and logistics. So we want to be able to basically, instead of going in and cleaning up a minefield in the dangerous situation, we want to be able to turn it on remotely, deactivate it remotely, and then go in and clean up whatever we need to do. It makes it a much safer, capable program. So that's what we're trying to do here. Once again, the technology manager is Patrick Carver. Author one is, I'm not going to pretend to pronounce his name correctly, but I'll give you his phone number, 850-234-4576, and Thomas Frederick at 850-234-4130. The next topic is for our Cobra program, and I always refer to Cobra as the program that SBIR built, because the APM on the Cobra program has a very effective use of SBIR technologies in his program. And so he plans for it, he maps for it, and he really does a really great job of utilizing SBIR in the Cobra program. And this is another one of our techniques to get the man out of the minefield. So what the Cobra program does is it uses 6 multispectral bands to image various minefields and do mine detection through different imaging sensors and systems. And so this is typically mounted on the Fire Scout radar, so or the Fire Scout UAV platform, and it goes in and basically tries to detect mines in different environments, and they've really had some great success with it as a SBIR program. So what this SBIR aims to do is it aims to basically do a hardware in the loop test bed for different SBIR sensors and technologies to minimize the cost of data collection as far as the Cobra program goes, because to use various sensors and various simulations gets to be very expensive, so they want to do something that mimics and simulates a test of the equipment and the technology. So the SBIR technology manager, once again, is Patrick Carver. Author number 1 is Dawn Clamser. She is the senior engineer involved in the Cobra program, and she's really very, very knowledgeable on these technologies. Her phone number is 850-230-7148, and Brian Bowen, 850-235-5780. Our next topic is the Joint Tactical Radio System, compliant anti-jam waveform for LCS unmanned vehicle beyond line of sight. And this goes into our MVCS, our multiple vehicle communication system, MVCS. It's going to transition through 420. And right now we have a current SBIR that is an anti-jam capability for the RT-1944U radio system, which operates in the line of sight. So now we're looking for a communication system, anti-jam capable, that will operate in the beyond line of sight scope. So the technology manager on this is Patrick Carver. The author is Jay Doan. His phone number is 850-235-5883. And Eric Gadd, 619-553-6041. Our next topic is an STTR. So this has a certain element of research facility that would be required. And once again, it's another weight saving measure for LCS, building on our high temperature superconductor technology. And it's basically development of an insulated power cable, and that will kind of keep itself cool. So that's going to take the temperature down. As I mentioned before in the previous topic, we have a consideration with keeping the cryogenic spaces in the proper temperatures, and so that's what this is referring to. There's also a consideration with this one that's not on the slide. The cost goal on this is to develop the technology not to exceed $25 per meter. So there's a weight consideration as well as a cost consideration with this one. The TM is Patrick Carver. The author is Dr. Jacob Kephart, which is 215-897-8474. And the other author is Jason Miller, 215-897-8925. And once again, if with any of our topics, I work pretty closely with all of our APMs. So if you have any specific questions and you can't get a hold of anyone, please reach out to me and I can kind of track down those answers for you. So, thank you.